We're going to prove one last theorem here. This is A or not A, which is sometimes called the law of excluded middle, because what it says is that every sentence has to be true or false. There's no third options. Um, and then, in keeping with this actually doesn't hold in logics that have three or more truth values. It's something that only holds in a two-valued three-functional logic. So we start off, right, by taking the theorem itself to be our goal sentence. Now, the question is then, how are we going to derive this? So one thought you might have is, since this is a disjunction, you could try using disjunction introduction. So in that case, what you need to do is you need to derive one of the disjuncts, and then you'd use disjunction introduction to introduce the other disjunct. So, for example, we could try deriving A and then, right, use or introduction to, to introduce the not A. Um, However, there's a problem with this. So, since this is a theorem, right, there's no scope line over here. So, there's no scope line here either. So, in order to get this, what you'd have to do is you'd have to prove A as a theorem. And well, you can't do that. You can verify that you can't do that by looking at a truth table, right? Because remember that if um, if a sentence is a theorem, then it has to be truth functionally true because of the soundness and completeness of SD. So if you look at the truth table for A, what you can see is this is not truth functionally true, which means it's not a theorem. So proving it here with no scope line to the left is not going to be possible. So that strategy is not going to work. And it's going to be the same for not A. You could run through make the truth table for not A, and you could see the same thing, right? It's not going to be possible to prove that as a theorem because it's not truth functionally true. Okay, so the only option that really leaves then is negation elimination. So we would need to introduce a new subderivation. We assume the negation of the theorem for negation elimination. Now, this though probably looks like it doesn't actually improve matters very much. Right. So, I mean, first of all, there's nothing that we can do top down here because it's a negated disjunction. There are no elimination rules that apply to a sentence of this form. As for goal sentences, what we're looking for is some pair of sentences that contradict each other. And the usual rule for that is look at the sentences that you already have in your derivation and try to find um, look at something there, see what you have, and then try to find the opposite of one of those sentences. But the only sentence that we have so far is this, right? The opposite of that is this, which is what we're trying to prove. I mean, if we knew how to derive this, we wouldn't have had to make this assumption in the first place. So, yeah, so here, it kind of looks like we're stuck. Um, Here's another place where it's a good idea to look at the truth tables. See, if you make a truth table for this sentence, and I have one here, what you find is this. This is truth functionally false. Um, so if it's truth functionally false, then the set that contains this sentence is truth functionally inconsistent, right? There's no truth value assignment on which every member of this set, right, all one of the members of that set takes the value true. And if a set is truth functionally inconsistent, then it's inconsistent in SD2. So there is a pair of sentences, that take the form Q and not Q, right? Where one of them is the negation of the other. There is such a pair of sentences that you can derive from the set. So, but this truth value or what this truth table tells you is we can derive a contradiction from from this line. Um, so in a case like this, right, where you know that you have an inconsistent lines in your derivation, but you can't see how to get a contradiction from them. Sometimes what you need to do is you need to make an assumption to sort of roll out the contradiction. That just, you just need to introduce a little bit more information to get the things going, to get the contradiction out there. But the contradiction is already implicit in this. Um, this isn't making an assumption blindly, right? Because remember what the cardinal rule of assumptions is, right? Don't make an assumption unless you know how you will discharge it. I actually went and made a motivational poster so that you won't forget this. But in this case, see, the problem with making assumptions blindly is you don't know how to discharge them. And we do know how we're going to discharge this assumption. We're going to discharge it, I mean, depending on exactly what sentence we assume, we're going to discharge it with either negation introduction or negation elimination, right? And we know that we can do that it's going to work because this set is inconsistent. So just to get things rolling, right, just to get the ball rolling, we will introduce a new subderivation, and we'll introduce a new assumption, which is just going to be A. And this will be an assumption for negation introduction. Now, we can get a contradiction here. And it'll be pretty easy to do that. We'll just get it by or introduction first. We use or introduction to get A or not A. So that's from 2 by or introduction. Then we will reiterate line 1. This is 1R. We have a contradiction there. So that means we have proved not A by lines 2 to 4. Negation introduction. Now, if not A is true, we can use or introduction again to get A or not A. 5 or introduction. That again. And then reiterate line 1 again. One R. And now we have another contradiction. And this one is in the main subderivation here, right? This contradiction applies to this assumption up here, which means that allows us to discharge this assumption. And we've proved this. This is then 1 to 7 negation elimination. Informally, you can sort of see that the reasoning here is we started off, we know that this is inconsistent, and then the way that we demonstrate that it's inconsistent is, well, we suppose that A is true. We show that that's not a possible scenario, it leads to a contradiction. That means that A must be false, but A being false also leads to a contradiction. And so then we get the result that this sentence has to be true. So a derivation's complete. Then all we need to do at this point is just delete these unused rows and fill in the scope lines, and we'll be done.